In this lesson, we'll talk about matrices and matrix operations. At the top of the screen, you'll see four matrices, and let's go ahead and give the dimensions of these matrices. Matrix A is a 2 by 2 matrix. Matrix B, 2 by 2 as well. Matrix C is 3 by 2. And matrix D is 2 by 3. And when you're writing the dimensions, the rows come first and then the columns. And having these dimensions will help us with our matrix operations. So let's go and look at some simple matrix operations. Let's do the matrix operation A plus B. And if we're going to do matrix operations with addition and subtraction, we have to ensure that the matrices are the same size. A and B are in fact both 2 by 2, so we can add these two together. And in finding the answer for the matrix operation of addition for this one, we simply add the places together. So with the 1 and the 2 that I've circled in red, add those two numbers together, and that'll be the first place in your answer, which would be 3. The second one would be circled in green, 3 and a negative 1. So 3 minus 1 is 2, and that answer goes there. The third one would be the 2 and the 0, circled in blue, so it's 2 plus 0. So the answer is 2. And the last one is 4 and 2, so I'll circle those in black. 4 plus 2 is 6. So the answer to that problem, A plus B, is 3, 2, 2, and 6. Now let's look at subtraction. And let's change the order, so we will do B minus A. Once again, the matrices have to be the same size. And there are two different ways to do subtraction. Basically what you're doing is you're adding the inverse. So first step, I would want to change all of the signs in the A matrix and then add those two together. So changing the signs in the A matrix, I would get negative 1, negative 3, negative 2, and negative 4. And now I change my operator from subtraction to addition, and I add these numbers together. So 2 and negative 1, so 2 minus 1 is 1. Negative 1 and negative 3, so minus 1 minus 3 is minus 4. 0, negative 2, so 0 minus 2 is negative 2. And 2 plus 4, 2 plus 4, oops, my mistake. 2 minus 4, let's remember where we're at. 2 minus 4 is negative 2. So the answer to B minus A is 1, negative 4, negative 2, negative 2. So as we're looking at these matrices, let's talk about scalar multiplication. Scalar multiplication is taking a number and multiplying it by a matrix. So let's, as an example, let's do a scalar multiplication on C. So we'll do 2 times C. And so what does that equal? That's the number 2 times the matrix for C, 1, 2, 4, negative 3, negative 1, 1. So every item in the matrix gets multiplied by 2, and that's the new result. So 2 times 1 would be 2. 2 times 2 would be 4. 2 times 4, 8. 2 times negative 3 is negative 6. 2 times 1, negative 2. 2 times 1 is 2. So there's the answer to 2C, which is scalar multiplication. And now let's look at matrix multiplication. The first one we look at, we're going to do A times B, or AB. And remember, the matrices have to be the same size when we do operations that are addition and subtraction. Now we're looking at the rows of A and the columns of B. If those match, then we can multiply them together. So we know that A is a 2 by 2 matrix and B is a 2 by 2 matrix. So what we're looking for are the inner two numbers to match that I've circled in green. So if those two match, and they do, that means we can multiply these two together. So let's write them out and multiply. A is 1, 3, 2, 4 times B, which is 2, negative 1, 0, 2. And what we're going to use is the A in the A matrix are the columns of A, and we're going to use the rows of B. So to get this answer, the first place at the top left would be 1 times 2 plus 3 times 0. So that answer is going to be 2 plus 0, so that answer is 2. We stay with the same row, but we go to the next column. Keep moving in your columns to the right on B. So we'll have 1 times 2 plus, oh, my mistake, not 1 times 2. 1 times negative 1. Let's try that again. 1 times negative 1 plus 3 times 2. So 1 times negative 1 is negative 1. 3 times 2 is 6. So 6 minus 1 is 5. So that would be a 5. Now, since we run out of columns in B, we go back to the next row in A. So that would be 2 times 2 plus 4 times 0. Notice how the columns stay the same. Notice how those match, and we just move down the rows. So 2 times 2 is 4. It's 4 times 0 is 0. So that would be 4. And now we do the second row and the last column of B. So that's 2 times negative 1 plus 4 times 2. Once again, those columns match up. Notice how they stay the same. So 2 times negative 1 is negative 2. 4 times 2 is 8. 8 minus 2 is 6. So what's the answer to that? 2, 5, 4, and 6. In our last part of matrix operations, let's take a look at another matrix, and let's see if we can multiply these together. We're going to, in this case, we're going to multiply D and B. So we know D is of the size 2 by 3, and B is of the size 2 by 2. Remember what we said earlier, the inner numbers for this matrix operation have to be the same. In this case, we have a 3 and a 2. They are not the same. So therefore, DB cannot be multiplied together. However, if we want to look at C and D as a multiplication, we can do that. We can only multiply one way. We can do C times D. We can't do D times C, because if D's first, we have more in the rows than we have columns. And so that's not going to be able to multiply. So for our last one, let's do C times D. C is a 3 by 2. D is a 2 by 3. Notice the inner numbers correspond. The outer numbers, 3 by 3, give us our answer size, so we know the answer should be a 3 by 3. So for the last one, 1, 2, 4, negative 3, negative 1, 1. And then we have 1, 0, 3, 2, negative 2, 1. So we multiply these out. The rows of the first one, so we use the rows of C, and we use the columns of D. So let's write those out. The first place would be 1 times 1 plus 2 times 2. So that's 1 plus 4, so that's 5. Go to the second row, or the second column, same row. 1 times 0 plus 2 times negative 2. So that's 0 minus 4, so that'll be negative 4. And I'm going to run out of space here, so I'm going to do the last one at the bottom. 1 times 3 plus 2 times 1, so that's 3 plus 2. So in this place is going to be 5. The second one, go to the second row since we've run out of columns. 4 times 1 plus -3 times 2. There again, once again, notice how the columns stay the same. That would be 4 minus 6, so that would be -2. 4 times 0 plus -3 times -2, excuse me. So that would be 0 plus 6, so that answer would be 6. And then we'll do the last one at the bottom. 4 times 3 plus -3 times 1. So that would be 12 minus 3, so that would be 9. So this last answer is going to be 9. So far, what we have is 5, -4, 5, -2, 6, 9. So since we've rewritten that, let's create a little more space here so I can fit the last row in. The last row is going to be the third row of C, so that would be -1 times 1 plus 1 times 2. So that would be -1 plus 2, so that's going to be +1. And then we have, so I'll go ahead and write that at the bottom. -1 times 0 plus 1 times -2. So that's 0 minus 2, so -2, that goes here. And then the last one would be -1 times 3 plus 1 times 1. So that would be -3 plus 1, that would be -2. So the matrix in red is our answer. 5, -4, 5, -2, 6, 9, 1, -2, -2.